Hi there, welcome to your lesson on periodic functions. Periodic functions are functions that model phenomena that go in cycles. For example, like we see on the diagram here. Tides come in and out, they go in cycles. It repeats. Those are periodic functions. So here's an example of periodic functions. They are functions, again, that have a repeating elements. The y values repeat over and over. So we can see a pink curve with repeating y values, and also the green curve also flows in cycles. It has repeating y values. So they're called periodic functions because a period is the amount of time or the distance it takes to complete one wave, one of the cycles. For example, here we have a periodic function, and one period is where you can take it from the beginning of one wave, follow the wave until you get back to there, and then it starts repeating. So the length of that one wave is called a period. So look at this diagram here. On the diagram down here, these are measures of waves in electricity. The pink waves measure watts, and the green waves measure current in amps. So tell me, what is the period of the pink waves? Okay, so if you understood what I was saying about period here, we can say period is the length of one wave. So we can say the pink one begins here, goes to here, and goes to here, and after that it repeats. So if you've gone through one full cycle, that's your period. And in this case, that goes from 1 millisecond to 2, therefore the period is 1 millisecond. Okay, what's the period of the green wave, the one measuring amps, current in amps? Okay, for the green one, we can take any slice of the wave, but I'm taking this one here where we have the dotted green curve. And the wave begins there, goes up, goes down, and comes back to here, and then it'll repeat after that. So that's the one period, or one cycle, and that period has a length of 2 milliseconds, because we go from 4 to 6 here, so the period is 2 milliseconds. Okay, those are periodic functions. Periodic functions can be graphed and drawn, and they can come from something called the unit circle. The unit circle is a circle. If you graphed it on the coordinate plane, it would have a center at 0, 0, and a radius of 1. So you can see here, this has a length of 1, a length of 1, a length of 1, a length of 1. And if you drew a radius in any direction, like this, for example, it would still have a length of 1. So that's a unit circle. In a unit circle, we can begin at this axis, spin an angle like this, so we're going to call the angle theta. And then once you spin an angle, you can draw the radius. Okay. Now, from there, you can say, well, the radius is 1 because this is a unit circle, so every radius here will be 1. You can drop this line down, and now we can think about what we know about basic trigonometry. In trigonometry, we know, well, let's call this y, first of all. Let's call this length y because it represents the y value. If you had a coordinate here, that would represent the height or the y value along this axis here. So let's call this y. To find y, we know we could do sine of this angle opposite over hypotenuse. So sine of angle theta equals opposite side over hypotenuse, and the hypotenuse is 1. And since in a unit circle the hypotenuse is 1, we can simply write this as y equals sine theta. We don't need that 1. It's just y equals sine theta. So now we know in a unit circle, if we want to find out this vertical distance, we just take that angle and take the sine of it, and then we find out this vertical distance. That's the key part of what we're looking at today. So let's take it a little bit further, investigate. Grab your calculator. We're going to be investigating what sine of theta looks like. So sketch this graph. Take a moment and pause. Sketch a graph like this with all these angle measures, and we have a unit circle here, and we're going to try some stuff. So first, let's begin with an angle of 30 degrees. We spun an angle of 30 degrees. We drop this down here, and we want to know how long that is. And we just said in a unit circle, if we can find the sine of theta, then we know how long that is. We know the y value. Okay, because opposite over hypotenuse, but the hypotenuse is 1. So let's find it. Punch sine 30 in your calculator. What do you get? Okay, it's 0.5. So now we know that has a length of 0.5. So at sine 30, I'm going to draw that, and notice these are the same height, yeah? And then we put a point there. Okay, there's our point. At 30 degrees, 0.5. Let's try the next one. Try 60 degrees now. Sorry, 45. So we spin an angle of 45, drop that down, find out sine of 45. Okay, it is 0.707. That means this has a height of 0.707. If this was the upper point of the unit circle, that would have a y value of 1. But here, this has a y value, or height, of 0.707. Okay, almost at 1. We can see it's almost at 1. Okay, so it's 45 degrees. I went up here. We have a point at 0.707 right here. Okay, next. Let's go to 60 degrees. spin an angle, draw that, drop the vertical line down. Again, we can use sine to find that distance. We're getting closer to 1 because 1 would be here, so we're getting very close to 1. Sine of 60, what is it? 0.866. Okay, 60 degrees. I'm going to take that segment, I'm going to put it here to show that it's the same height, and 0.866. Great, let's continue. Sine, oh, I'm going to go back in time. Let's go back to 0, because we kind of did these angles, but I want to go back to 0 and see what happens to sine of 0. So let's say we do no angle. Well, if there's no angle, you just go like that. You're not spinning the angle, so you're staying here. So how high are you off the axis? Like, what is your y value? How high are you on the y-axis if you haven't spun an angle at all? Well, sine of 0 gives us 0, and that makes sense. Since we haven't spun this angle, we're not raised above the x-axis. We're not up on the y-axis at all, so we have value of 0. So when you had an angle of 0, we have 0. Okay, so now let's jump back ahead to 90. Okay, so now we're at 90. If you spin an angle that's 90, all of a sudden your side is there. And you can't draw a triangle like we were drawing before. But you do know the y value. What's the y value when you go to here? What's the y value at 90 degrees? We're all the way on top of the unit circle. So you should already know, but confirming on your calculator, sine of 90 is 1. So at 90, we have 1. All right, good. We've gone up. All right, what's next? So now we have an angle of 120. Let's try it. When you go 120, you go beyond 90, you end up over here. Okay, so I'm going to draw a line like that. Drop the horizontal there. So here's 120 degrees. We created this triangle. But again, we need this distance, this height. So sine of 120, 0.866. Great. So at 120, we're at 0.866. Notice it's the same as that we had at 60. That makes sense because at 60, we're in the same place because this angle now is 60 because this makes 180. Halfway around the circle is 180. So this is 60. We're in the same place if we had 60 on this side. So 0.866 is our height there. Okay, next one. Let's try an angle of 150. Okay, when you spin 150 of a triangle, we're looking for this height, remember, and the height is given to us by the sine function. Let's try it. Sine of 150. It is 0.5. So 150, we're at 0.5. And notice I have the same distance here as here. Okay, a few more. Try 180. What happens when you spin 180? Okay, hopefully you saw that you end up back at this axis, so it's not raised up at all on the y-axis. You're flat here, so there's no value in the y-axis. And if you check on your calculator, it's 0. So there we have it, 0. Okay, 210. Let's spin all the way to 210. 210 brings us to this angle. Here's the distance we want. Notice now our y value will be negative, right? Because up here we had positive y values, but now we're below the x-axis, so these are negative y values. So we're trying to see what is the y value right here, right? How far down did it go down the y-axis? So let's figure it out. Sine of 210, put in your calculator, negative 0.5. All right, so 210 degrees, negative 0.5. We are right here. Okay, next one. Let's spin an angle of 240. Okay, we're here. Put the vertical line there. We're going to figure it out. Sine of 240, negative 0.86. Again, makes sense. It's negative because we're going down. So down on the y value is negative 0.866. There we have it. 240. We're right here. Okay, just a few more. We're going to go all the way to 360. 270 brings us to here. This is 90, 180, 270 brings us right to here again, 270 degrees. 270 degrees, we're here, so the y value goes all the way down here. It's that whole length there. So our height, our vertical height, you should confirm on the calculator is -1. Great, there we have it. All right, a few more. 300, spin 300. We're looking for this distance. Okay, find it. Sine of 300, negative 0.866. There's 300, negative 0.866 right there. Okay, and last one, 330. We've come almost all the way around the circle. All the way around would be 360. We're here, 330. So now we're looking for this vertical distance. So sine of 330 gives us negative 0.5. We're back here again. And finally, we've come all the way around the circle. Now we're at 360. We come all the way around. Well, if we come all the way around, then this is the line we're talking about. And how far above or below that line are you? Well, you're not. At 360, you're exactly at that line. So the y value must be 0. You're not going up or down at all. Check on your calculator. It is 0 for sure. So we're there. Hey, check it out. Look at this flow of this data we have here. This is called a sine curve. it is a periodic curve. It is the focus of our topic today. A curve that follows this kind of pattern, and it will follow that pattern forever to infinity. That is a sine curve. Let's see this on Desmos. Okay, so here is a sine curve. I'm going to press here. Okay, look, there's the sine curve emerging. As you can see, when you're here, there, the orange line represents how high off the x-axis you are, right? The height, right? It's the y value. That's what we're looking for. Look, here, negative y values. But when you get here, no y, and then look, positive y values, positive, 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 and then negative y values, getting bigger negative, then smaller negative, then 0 y value, then positive y values again. All right, and notice that these are given in measures of pi. That's called a radian measure for angles, but don't worry about those. We're dealing with degrees. The main thing is you can see that the y values create your curve, right? The vertical distance here creates your curve. All right, great. Awesome idea. Big important idea of mathematics. Let's go a little bit further with that. So let's say we had this angle of 34 here, and somebody said, what's this distance here? How would you do it? Well, you would do sine of 34, and then you'd say, well, that's 0.559. Okay, your calculator can give you that. So you know that this distance here must be 0.559. That's what that length is. And we can see that makes sense. Look, it's just above 0.5 on the y-axis. Great. So what if somebody gave you this one? Do you see any connection between these two circles? Well, there certainly is a connection. If you spin this 34 degrees here, but then you keep going into the second quadrant here, and you spin it, 146 gets you here. But then what's the leftover angle here? Well, if this is 180 to go halfway around the circle, that leftover bit must be 34. So we really have the same triangle as we have here over here. Okay, when we go 146, it's the same one. And if it's the same triangle, then that means this distance, vertical distance, must be the same because it's just this triangle and it's been reflected that way. So this number should be the same. Let's double check. Put one sine of 146 in your calculator. Let's double check. Yeah, it gives us the same value. Makes sense because again, sine represents that vertical height right there. Okay, another way to look at this is to graph it. And if we graph our sine curve, which we just created, which is here, and then we graph the line y equals 0.559 right here, because we're trying to see when y equals 0.559. So here's 0.559. Notice that, and we've done this kind of thing where we graph two curves and find the solutions. This curve hits this line at two places right here, and it will into infinity over here also. But here, notice it hits it at 34 and 146. So it tells us as 34 degrees, the y value is 0.559, and at 146 degrees, the y value is 0.559 also. All right, important connections we're seeing here. Let's keep going a little bit further. Okay, we can also look at this a different way. What if we said this one? Do you see a connection between this and the upper two circles? Look at the angle we've spun now, 214. We've come all the way around past 180 and all the way to here. Is that triangle the same as the two upper triangles? Yes, it is, because here this is again is 34 degrees. Because if we go 180 halfway, then we need an extra 34 degrees to get 214. So this is also 34 degrees. So what does that tell you about this value of sine of 214? What should it be? Well, in this case, I hope you didn't say it's 0.559 again, because it's actually negative 0.559, right? Important connection we have to see here, right? The sine gives us the y value, and here the y values are both positive. Here now the y value is negative because we're going below the x-axis. But it's a negative distance that's identical to these ones because the angle here is the same. So it's the same number, just negative. Okay, how about this circle here? Do you see a connection? We have now spun 326 degrees. Okay, if we spun that far, this angle again is 34. So we're seeing all these cases where the angle 34 appears. This is 34 again. And because if to go all the way around would be 360, but we do 360 minus 326, and we find out that we're 34 degrees short of 360. So again, we have the same triangle, that one with 34 degrees there. And if we're looking for the sine value of that full angle, it's going to give us the y value, right? The vertical distance. So what is this vertical distance? Okay, just like this one, it was 0.559 but negative because we're looking at negative y values. Very important slide to kind of show us all these ideas here. So pause if you need to and just kind of study that. Okay, so we'll continue in a second video where we'll begin with the unit circle again and mention a couple other things. So this lesson comes in two parts. Please go watch video 2 now. See you soon.